Okay, so we are going to discuss something called transformation technique. Transformation technique. Transformation technique is basically meant to make your data normalized form. Okay, it is basically used to make your डेटा नॉर्मल डेटा को नॉर्मल बनने पे बेसिकली एटा यूज हुए ओके डेटा को नॉर्मल बनने को बेसिकली एटा यूज हुए व्हाट इज नॉर्मल नॉर्मल डिस्ट्रीब्यूशन गॉसियन डिस्ट्रीब्यूशन बेल शेप्ड कर्व स्क्यूनेस को काट दबो something you would be getting something like this okay is it going to purely make the data normal पूरा completely data को normal बने दबो कि outlier वगैरह सब हटे कि no 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 but it will try to make your data normal. It will try. It is just like you should be trying yourself to get into the perfection, although you know that you can never be a perfect guy, but still you can try to become perfect. Keep on trying. Fine. Suppose exam is going to be conducted, you are targeting to achieve 100 तम target रहा दरकार यदि 100 target रहिबो ताले तमे 95 96 जाय पहुंच पारिबो fine 100 out of 100 is quite challenging to get is not it the पिला 99.8% रे भी रहि जाउछथि but exactly 100% आनिबा is tough anyway you have to target for 100% in the same way transformation technique will try to make your data normal fine so try करिवो skewness value को skewness माने कोन outlier अछि skewness means we have outliers okay either this side or that side anything so it will try to shrink your outlier it will not remove your outlier remember shrink your outlier outlier affect to decrease कर दो shrink your outliers or completely decrease the effect of outliers so decrease कर दो decrease the effect of outliers in order to decrease the effect of outliers go and use something called transformation this is not outlier analysis technique this will not remove the outlier this will not modify the outlier it is not like vinsorization okay it is something called transformation it will be trying to make your data normal find data को normal बनेगा केमती एक तुम्हारा columns for example it is given like this 25 30 40 20 25 like this something is given and you got to know that this is not normal तम पाइलो केटा normal नुहे बहुत सारा variance ଅଛି variance is more if variance is not stable then we can tell that okay the data is not normal fine if it is not normal can we do some mathematical operation over it yes yes ଆମେ logarithmic ପକେଇ ଦେଇ ପାରିବା log base 10 ଆମେ exponential ପକେଇ ଦେଇ ପାରିବା ଆମେ square root ପକେଇ ଦେଇ ପାରିବା can we go for cube root yes yes we can also go for cube root can we go for reciprocal yes we can go for reciprocal so these are manually to be tested ଏସବୁ ଏମିତି ମ୍ୟାନୁଆଲି ଗୋଟେ କଲମ୍ ଭିତରେ ଏଇସବୁ ଜିନିଷ ପକେଇକିରି go and test whether your data become normal or not fine now how to check whether your data got normal or not ପକେଇ ତ ଦବା ସବୁ can we check it yes yes we can check it go and plot kd plot job kernel density estimation plot go for histogram if you want hist plot or else there is something called qq plot this is known as quantile plot or we can call it as probability plot prob plot these are different types of plottings fine plottings are basically there to help us visualize the things okay whether the things are normally distributed or not whether how is the shape of distribution whether we have outliers or not so देखियाकू diagrammatically we have something called plottings okay? These are different kinds of plots so here specifically a famous plot is used that is known as qq plot qq plot is basically used here fine quantile plot we call it also as probability plot ago probability plot भी କୁହାଯାଉଛି okay so what this plot will be doing this plot will be helping you to provide a theoretical normal line ଗୋଟେ theoretical normal line से पके दबो तापर से बाकी जो पॉइंट्स गुड़ा का अच्छी that means your original data your real data whatever you have be it salary be it age or whatever suppose this is a salary column तो salary column ର प्रत्येक value को plottings କରିବାକୁ try करियो it will try to plot the things based on a formula that formula is z equals to okay x minus mu by sigma based on this okay it will try to plot those values ଏସବୁ ଏମିତି ଏମିତି ପ୍ଲଟିଂ କଲା ତମ କାମ ହେଲା as a user you need to observe whether these points are lying over the line or not if they are lying ଯଦି ସବୁ points ଗୁଡାକ line ଉପରେ ଏମିତି lie କରି କରି ଯିବ Deviation যদি হবনি, that means your data is normally distributed. You can tell that yes, my data is normally distributed. But if your points are lying like this, okay, your points are something like this, इधर उधर करके है, they are not lying over the line. If they are not lying over the line, that means they are not overlapping over the, you know, normalization criteria. Okay. If such is the case, if you are getting these blue points, that means points are not lying over the line. Go and do some mathematical operation over your column. Randomly go. Okay, randomly go. Best one is nothing but np.log. Try to apply logarithmic np.log over your entire data set, means entire column. तो प्रत्येक वैल्यू अगर लॉग 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 लगिगला, ଯଦି ଲଗ୍ ଲଗ୍ ଲାଗିଯିବ, values are going to be diminished. values ଗୁଡ଼ାକ ଛୋଟ ହେଇଯିବ, ପ୍ରତ୍ୟେକ value ଛୋଟ ହେଇଯିବ, values ଗୁଡ଼ାକ ଚେଞ୍ଜ ହେଇଯିବ। ଯେତେବେଳେ ଚେଞ୍ଜ ହେଇଯାଉଛି, they are coming to a particular form। ସେ ଗୋଟେ ଫର୍ମରେ particular ପଳେଇ ଆସୁଛି। ଧର 50,000 is greater than 20,000, you may be getting something called 2 or 5. So obviously 5 is greater than 2, but difference is not that much। Okay, in this way जो आउटलायर्स गुड़ाक थिला से माने श्रिंक हे गले, स्टिल दे आर आउटलायर्स बट स्टिल माने से माने श्रिंक हे गले, दे got shrinked। previously we had big values, right now we are getting small values। so it may, I'm not saying it will, it may help you to get your data in a normal form, in a normal way, normalize କରିବାକୁ try କରି ଦେଇ ପାରିବ। okay, if logarithmic, okay, you did the things and you got a new column, you got a new column, ଗୋଟେ ନୂଆ column ପାଇଲ, ପୁରା ଡେଟାଟା log ହିସାବରେ ପକେଇକିରି ସବୁ ପଳେଇ ଆସିଛି values। now apply this data, or apply this column over this graph। ଏଇ ଗ୍ରାଫରେ ପୁଣି plotting କରିଦିଅ, let's see, are you getting all the points over the line? If you are getting, then you are done, that means you made your data normalized। Remember, guys, all the points mandatorily not be required to be present over the line. Okay, it is not mandatorily required, but at least 90% of the data should be present। କାହିଁକିନା ମୁଁ କହିଲି ये आउटलायर को कटेबनी, ये आउटलायर को श्रिंक करिवो, ता इफेक्ट को डिक्रीज कर दो। Okay, but outliers are not going to be removed permanently। if outliers are not going to be removed permanently, that we can expect that some points would be lying over the line, below the line, or somewhere else, but not on the line। Okay, that's completely fine. We can accept that. If few of the points are not lying over the line, that's completely acceptable. But 90% of the other information or other data should be lying over the line. It's not you. Then we can make a conclusion that yes, our data got normalized। If your data got normalized, is it going to be helpful for our projects? Why? Actually, why we are making our data normalized? Remember, there are some of the machine learning algorithms. See, whatever we are doing in order to go for prediction in future, go for classification in future, go for forecasting, something like that। Okay. So this technique can be avoided by data analyst, but from a data scientist point of view, if in future you are going to use some of the machine learning algorithms like regression is a very good concept. Over that, we have different models. We have linear regression, we have multiple linear regression, we have logistic regression, we have lasso regression, ridge regression, ordinal regression, nominal। So these are different types of regression techniques। Fine। So regression techniques comes with one assumption। ସେମାନେ assumptions କରିକି ଆସନ୍ତି। এই ମଡେଲଟା ତେବେ କାମ କରିପାରିବ ଯଦି ତୁମ ଡେଟାଟା ନର୍ମାଲ ଥିବ। LINE, we call it as LINE, linearly distributed values between your input and output। errors should be independent of each other। n errors should be normal। data point should be normal। data point normal ହେଲେ ସିନା ତା error ଗୁଡ଼ାକ ବି normal ହବ। n e is nothing but errors should have equal variance। fine। so এই assumptions ଭିତରେ ଗୋଟେ assumption ଅଛି କି ଡେଟାଟା normal ଥିବା ଦରକାର। ଆଉ ଯଦି ତୁମ normal ଅଛି ଡେଟା, ଆଗରୁ ଯଦି normalize କରିକି ଆସିଛ, ଆଗକୁ ଯାଉଛ, then it will work fine। or else it will still work, but you won't be getting your desired output ki, you know what is that, accuracy पाइया टी कष्ट ହେଇଯିବ। that's there you again you have to struggle। so better ଯଦି प्रीप्रोसेसिंग କରୁଛ, ସବୁ step side by side କରି ଆଗକୁ ଯାଅ, କିଛି ଅସୁବିଧା ନାହିଁ। okay, it is just like drinking water। if you drink water 5 liters a day, 6 liters a day, or 2 liters a day, 1 liter a day, ultimately it is going to benefit you, is not it? Yes, we say that, yeah, you have to drink at least 3 liters of water per day. Fine, but drinking water is necessary. If you don't drink, then something may happen. Okay, so ଯଦି normalize କରିଦେଉଛ, that's fine। ଇଏ ଗୋଟେ advantage ହେଇଗଲା ନା, ଆଗକୁ ଯାଅ machine learning ରେ ପକାଅ, କିଛି ଅସୁବିଧା ନାହିଁ। Okay. Now these are manually you can find it out. We from mathematics point of view we call it as transcendental function. Okay, if you use something called logarithmic, exponential, okay, some of the trigonometric functions. You can also use sine. You can try out. NP dot sine. Go and try out NP dot cos, NP dot tan. Okay, you can keep on trying these things. Keep on trying these things. If your data getting normalized, that's completely fine, and you kept on trying the things and you didn't get any desired result, ଥକିଗଲଣି ସବୁ ଆପ୍ଲାଏ କରି କରି, ତମେ କିନ୍ତୁ ଡେଟାଟା ନର୍ମାଲ ପାଉନ, ସବୁ ପଏଣ୍ଟସ୍ ଗୁଡ଼ାକ ପ୍ରାୟ ଉପର ତଳେ ସବୁ ଆସୁଛି। At that time, go for some specific cases. Okay, for transformation, we have some specific techniques in order to do the transformation. We call it as box box technique. We also have something called Yo Johnson Yo Johnson technique. We have something called box technique or Yo Johnson technique. Box and Yo Johnson techniques are basically required in order to make your data in a normal way, to do the transformation. They automatically will do. You don't have to bother about कोड log use करिवे कि exponential use करिवे। Simply तुम्हें SciPy को जाओ, SciPy रे stats ଗୋଟେ module ଅଛି, go for the module called stats। From that, keep on inputting the things, keep on inputting the things, something like we call it as box। Import box। Go and input use on sir, input कर दियो, that means this functions got imported। अब यही फंक्शन भितर ଗୋଟେ parameter ଥାଏ lambda। Lambda is a parameter. A parameter is there. The parameter's name is lambda। Lambda. From physics point of view, you can call it as wavelength. Okay. So this is known as lambda। Lambda. So this lambda values varies from -5 to 5. Okay. And this lambda value is basically calculated because of a function called log loss, and you shouldn't be worrying about that function. See, internally se kaam kare। The log loss function achi, there is a function called log loss। A very big function is present। Very big function is present। तो से सेई फंक्शन हिसाब रे से लैम्बडा वैल्यू कैलकुलेट करने ट्राई करिवो। बेस्ड ऑन दैट पर्टिकुलर फंक्शन, इट विल कीप ऑन iterating to get the desired lambda value। Desired lambda value should be lying in between -5 to +5, and those things your Python will do। You shouldn't be worrying। से कोडा दबा आमे जानू किंतु से दबो, it will give you a lambda value in such a way that if you apply one formula called, let me go on, x plus 1 to the power lambda, you know minus something something divided by to the power lambda, something like this। Okay, let me go to that formula। The formula is even not at all required to be remembered anyway। If I go and showcase you that formula, it will be there in the presentation। Okay, so we have a formula। যদি এই formula রে যদি lambda value টা পকাইব, is it machine learning? No, we are reading pre-processing tech। Then you would be getting some output। Suppose you got the first row, the first row re, or for example you have a salary column, you have something called 20,000। Go and put it in this formula। What a lambda value pi है, you got a desired lambda value। Let your lambda value is 2। -5 to 5 भीतर से तारा try कला log loss function को use करी you got something called 2। से 2 को यदि मैं नहीं करी ये formula रे पकेबी x plus 1 to the power lambda plus 1 divided by lambda, something like this it is clear। Let me go and verify it। Yeah, here you can see the formula is x to the power lambda minus 1 divided by lambda for box। So this formula is internally going to be used। Lambda value टा पाई जाइए, प्रत्येक x value नबो। For example, you got your first x value as 20,000, you got your second x value as something, third x value as something। Take those x values, put here to the power lambda minus 1 divided by lambda। Okay, you would be getting some output। ये वाला output पाइलो, simply ये वाला output पाइलो, simply ये वाला output पाइलो। Keep on getting this output, and these are going to become your new column। ये सब तो new column is। But एमती भी कथा अछि, अरे what if I am getting lambda value as 0? Something by 0 is nothing but infinity। I am not going to get that solution। So if your box box is giving you lambda value as 0, it will not use this formula. It will not use this formula. It will use something called log x. It will simply take logarithmic of that particular x, log base 10, and you would be getting that output. See, এই হিসাବରେ ତମକୁ ଗୋଟେ ନୂଆ କଲମ ନ୍ୟୁ କଲମ ବନେଇକି ଦେଇଦେବ. It will give you a new column. Are you guys there? ଆଉ କ'ଣ ମୁଁ ଏମିତି କହି ଚାଲିଛି and oh, fine. Okay, am I audible, everyone?
Yes, sir.
Oh,
Yes, sir.
okay. So this is how it works. Okay, box box technique is a very powerful technique, but the demerit of box box technique is that this technique works only for positive data, zero or positive. Positive greater equals to zero ପାଇଁ ହିଁ ସେ କାମ କରିବ. What if we have negative data? For example, we have something called a column called loss or profit. We have a column called profit. Profit with the positive also, that's fine. If my profit is minus 2000, minus 2000 means it is loss, minus negative, is not it? If negative values are present, you cannot use box box. At that time, you should be going for something called Yo Johnson. Yo Johnson transformation. It will work in the similar way. It will also find out lambda value, but this time the formula for Yo Johnson is completely different than box box. ଏଥିରେ ଟିକେ change ଆସୁଛି. ଏଥିରେ x to the power lambda ଥିଲା. Right now it is x plus 1 to the power lambda minus 1 divided by lambda. If your x value greater equals to 0, fine. And if your values are less than 0, box course will not work, but U Johnson will work. If U Johnson is working, if it finds that your x value is a negative value, then it will be putting the use of this formula. If formula is usable. And it's not required to remember the formula. Why? Because no one is going to ask you the formula it is going to be used. Anyway, if you remember, then that's an advantage. ଏଥିରେ ଟିକେ ଚେଞ୍ଜ ଆସୁଛି ଏଥିରେ ମାଇନସ୍ ବାହାରେ ଗୋଟେ ମାଇନସ୍ ଅଛି ଆଉ ଏଥିରେ ମାଇନସ୍ ଏକ୍ସ ପ୍ଲସ୍ ୱାନ୍ ଟୁ ଦି ପାୱାର ଟୁ ମାଇନସ୍ ଲମ୍ବା divided by 2 minus lambda. If your x value is less than 0, it will be using this formula. And obviously, lambda value could be anything. Okay. But it shouldn't be equals to 2. If the 2 is 0, then denominator 0 is 0. Okay. If your lambda value, in case Rio Johnson transformation is giving you the lambda value as 2, then neither this nor this, none of the formula is going to be used. It will go for something called this one, E formula. Minus log minus y plus 1. Okay, and this y is nothing but this x. ଏଥିରେ x ଅଛି, ଏଥିରେ y ଅଛି. So this is nothing but x. If you have a negative number, if y is less than 0 and lambda equals to 2 you got, then it will try to implement this particular formula. Internally everything will happen. You shouldn't be worrying about anything. Only thing that you need to remember is when to use box box, when to use Yo Johnson. Okay. If you have negative data, then go for Yo Johnson. If you have positive data, then you can go for box box or Yo Johnson. It is completely depending on you. Ultimately, you need to get your data transformed. For a normal form, that should be your goal. Okay. And this is all about which function it's going to be used, which particular formula, and based on the conditions. If y value greater equals to 0 and lambda is not equals to 0, it will use this formula. If lambda equals to 0, in case here the lambda value is 0 at the denominator, then what will happen? It will not work, is not it? Something by 0 is infinity. There it will be going for this one, log y plus 1, if your lambda value is 0. If your y value is less than 0, that means negative number, and lambda value not equals to 2, it will figure out this formula. And if y value is negative and your lambda value is also 2, denominator condition, then it will go for this formula. So these are some formulas. If you want to remember, that's fine. If you don't want to remember, that's also fine, because no one is going to deep dive into these formulas and all. Okay. Anyway, so this is the technique that we should be learning today. So this is all about the theoretical things. And yes, manually you can try out first. Go for something called logarithmic. Most of the time, logarithmic will work fine. If it is not working, try out with few of the other things. Go for reciprocal. Reciprocal means 1 by that value. Go for sine, go for cos. Experiment these things. Experiment these things. And you tried out, 5 to 6 functions and didn't work out. Then go for box, go for Unison. at the end. Okay, and high probability is there कि this out of these two techniques anyone will work. Ultimately, you have to make your data transform. That's it. That should be a goal. Okay. So if I go and showcase you the code of this, just have a look. But technology is advancing in such a way that we should keep on upgrading ourselves. Why? Because recently DeepSeek came into picture. DeepSeek, a Chinese company, DeepSeek, 2023 ରେ found ହେଇଥିଲା କେତେ recently just founded ହେଇଛି and a startup company, and they came up with a genetic model that is nothing but DeepSeek model. Okay, DeepSeek chat GPT को पूरा heavy level ର competition ଦେଇଦେଲା. Chat GPT in the sense OpenAI company को. OpenAI, literally, Elon Musk has used billions of dollars in order to develop this particular generative tool. But DeepSeek से $6 million रे ହେଇଗଲା. $6 million रे ମାତ୍ର $6 million ରେ DeepSeek ବାହାର କରିଦେଲା ତା ନିଜ ଜିନିଷ, and it is giving competition to ChatGPT. Fine. And if you ask me कि भाई दोनों से कौन सा वाला अच्छा है, I will prefer this one. Why? Because for me, ମୋ point of view ରୁ ମତେ ଏଟା ଭଲ ଲାଗୁଛି. Why? Because ସିଏ line by line ପୁରା ଜିନିଷ ଗୁଡାକ ଦଉଛି in a proper format. Okay. Chat GPT କେବେ କେବେ randomly items ଗୁଡାକ ଦେଇଦିଏ, but DeepSeek ଠିକ ଠାକ ସେ ଦଉଛି. And coming to mathematics, DeepSeek is working fine. Okay, mathematics ରେ ତାକୁ percentage ମିଳିଛି 97, ଚାର୍ଟ ଜିପିଟିକୁ 96. ଓକେ, ମ୍ୟାଥମେଟିକ୍ସ। ସୋ ଦେଖ ଏତେ ଛୋଟ କମ୍ପାନୀ ଏତିକି ଟଙ୍କାରେ ତା ନିଜ ପ୍ରଡ଼କ୍ଟ ଡେଭଲପ୍ କରିଦେଲା। ସୋ ଇଣ୍ଡିଆ ଇଜ୍ ଅଲସୋ ଆପ୍ରୋଚିଂ ଟୁୱାର୍ଡସ୍ ଦ୍ୟାଟ୍ ପର୍ଟିକୁଲାର ଗୋଲ୍। ରାଇଟ୍ ନାଉ, କମିଂ ଟୁ ବାଙ୍ଗଲୋର, କମିଂ ଟୁ ହାଇଦ୍ରାବାଦ, those companies are they want to get those candidates or those students or those employees who are basically ready to work for LLM models, large language models. So behind the scene of these things, we have LLMs, models, different models. DeepSeek रे R1 model use होची. Chat GPT पछरे we have something called GPT model. Fine. So these are different models, and behind the model we have some mathematics. Behind some model, we have some architecture. Just like a normal machine learning model, these models are also going to work out. तो यही सब मॉडल विषय रे टिके फेयर आइडिया तुमको थिबो. That means you know something regarding LLM. At least you can tell your interviewer that yes, I know how GPT works, how chat GPT works, how it works behind the scene. बाहर मतलब आगटा तो समझते जानुचंती user is simply using the things, but केमिति बना ହେଇଛି, how the products have been developed. So these things if you are pretty much aware of, then your selection chances will increase. Okay. सो देख गोटे टाइम थिला मशीन लर्निंग नुआ समस्त लगुला, बट एबे कॉमन हो गलानी. देखा गले पाखापाखि कॉमन हो गलानी. एबे डीप लर्निंग को अधिक फोकस करा जाउछि. Anyway, so we have the code here. If I go and showcase you data pre-processing, that's fine, 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 fine. And which data we should be using here? We should be using something called education dataset. Pandas PD, and let me use this one, education dataset. Let's have a look. Oh, it's not coming up to my variable explorer, maybe because of some setting issues. And keep on remembering different libraries that we are using. Library को मन रखिया important. Why? Because from data science point of view, you should be focusing on library rather than heavy level codings are not required that much here. Why? Because we are not developers. Fine, let me go and import it. Okay, I imported this one, and this data set we had also seen before. Data serial number, workx gmat. Workx is nothing but work experience of employees based on months. So months हिसाब से देछि. GMAT is nothing but the scores, GMAT scores. Okay, GMAT is a very good exam. Okay, if you want to pursue your higher studies, you can go and apply for GMAT. So from scipy.stats as stats, scipy is a library, very famous library for advanced mathematical calculation, and we have a model called stats, statistics. Just input it as stats. Any nickname, any alias you can give, alias. Okay, PyLab, Python lab. So this PyLab is just like your matplotlib. You would a tool matplotlib ର ହିଁ ଗୋଟେ ଅଂଶ. It is a part of matplotlib. Fine. Although it is a module here, this contains everything regarding the plottings. ସେ plotting ବିଷୟରେ ବି ତା ପାଖରେ functions ଥାଏ, ତା ସହିତ basic mathematics ବି ଥାଏ, basic mathematics. So ଦୁଇଟାକୁ ଜିନିଷ ନେଇକିରି ଏ ମଡେଲଟା ବନା ହେଇଛି. So this module PyLab, it is a part of your matplotlib. It contains the tools to do the plotting as well as some basic mathematics. PyLab. Okay. If you go to the next one, matplotlib, you know what matplotlib? Matplotlib.pyplot as PLT. It is basically used for plotting. तो पाइलैब रे कौन रोचे? पाइलैब रे मैटप्लोट्लिब रे भी किछटा फंक्शन रोचे प्लॉटिंग्स पाई ता सहित कैलकुलेशन पाई भी किछ ना किछ जिंस रोचे. ओके पाइलैब. Okay. Now from stats is nothing but the scipy.stats. आपको ही हमें input करचु from statistics. From statistics, we have a plotting called probability plot, prop plot, probability plot. That is also known as QQ plot. तुम कहली QQ plot. ତା ଭିତରେ ମୁଁ କୋଉ ଜିନିଷର ଦେଖିବାର ଚାହୁଁଛି, I want to find out the data distribution of GMAT score of which particular this one table or data frame education. From education, let's go and find out the probability plot for GMAT. Coming to distribution, go and give a normal distributed line. This is nothing but a theoretical line which is going to be plotted. But a theoretical line plot hijiba ape ape. That is the reason why we have given norm. Can we give exponential? Yes. Can we give uniform? Yes. You can give anything of your choice. But we are interested to make our data normal. That is the reason why we should be plotting one normal distributed line, theoretical line. Plot equals to pylab. Plot equals to pylab. Okay. Plotting. ଯେତେବେଳେ plotting କରିବ pylab use କରୁଛ. If you want to use pylab, if you use PLT, that's also fine. That's completely fine. As I told you, pylab will do some internal calculation, just like ଯଦି ମୁଁ normalize କରିବାକୁ ଚାହୁଁଛି, if I want to give logarithmic, so taking pylab will help us to do the plottings. Okay? I will tell you how it will be going to work. Let me go and run it. If I go and run it, pylab is not defined. Why? Because I didn't import it or what? Yeah. Now it's also fine. Now see here. If I go on plt.show, matplotlib.show, so मतलब दिखाओ, it will be showing you something like this, as you can see here. This red line is nothing but your theoretical normal line. And as I told you, if your data points are going to lie over that line, that means your data is normally distributed. What can I tell about this particular figure? Can I tell that data is completely normal? No, no, no. Why? Because here most of the points are lying. That's fine. That's fine. But coming to this particular location, data points are not lying over the line. Maybe these are your outliers. Maybe these are different from other values. Okay. Let's go for workx. This is something that we plotted for GMAT. Let's go for something called workx. Workx ପାଇଁ ଯିବି ଆଉ ମୁଁ plot କରିବାକୁ try କରିବି. Let me go and plot it. That's fine. And if I go and show it, that's also fine. Now tell me, is it normally distributed? Is your data points normally distributed? Are all the points coming over the line? No. All the points are not coming over the line. Why? Because as you can see here, see these things. These are not part of your line. That means still here we can say that data is not normally distributed. Now let's go and do some transformation. As I told you, can you use logarithmic? Yes. Education.workx तो अच्छी अच्छी तब पूर्व खाली लिख दियो log. And log is a part of numpy. Remember, directly log use करियो. That is the reason why import numpy first. Make the use of numpy. तापर logarithmic होगा. np.log that particular column.
So
Distribution.
your voice
My voice is
is
not coming.
breaking.
Is it fine now? Okay, wait. Fine. Is it coming now? Is it fine right now?
Yes, yes.
Okay, see here. So here the data is not normally distributed. Okay, we need to make our data normally distributed. That means the transformation has not happened perfectly. In order to make our transformation happen in a proper way, we should be putting some transcendental function. So here I put log. But let me go and run this line. If I go and run this line, and if I go and showcase you my figure, it would be coming up like this. See, देखो logarithm में पको पको से पूरा normal बना देगा. Data points are coming just above the lines. Okay. If I go and showcase you those values, देखो मैं तुमको education.workx को जाके इतनी run करेगी. Let me go and run only these things. Till this, let me run it. अरे stuck. In the same way, in case your logarithmic is not working, go and try out exponential, go and try out sine, go and try out cos, whatever possible, which are part of your numpy, go and try it. देखो, as you can see my console, my values are 2107. देखो 2107 रे कितने difference? 57, 99. These were your original values, education.workx. But if I go and use logarithmic of this particular column, it would be coming up like this. See here. 3.044 4.67 सो लॉग पड़गला जो लॉग पड़गला वैल्यू गुड़ाक श्रिंक होगला जब श्रिंक है तुम देख डिफरेंस के कमी जाऊँ प्रीवियसली फॉर द फर्स्ट टू रिकॉर्ड्स ह्यूज डिफरेंस 2107 राइट नाउ इफ यू सी डिफरेंस इज वेरी लेस नियरली अबाउट 1.5 nearly fine so difference got reduced since the difference getting reduced the outliers effects are decreasing effects of outlets are decreasing outlets are not decreasing outlets are not getting removed or getting modified their effects are decreasing because they're getting shrinked they're getting shrinked fine can I use something else yes go for exp exponential let me go and run it and meanwhile just put plt.show here if I go and run it देखो exponential पकेले से पूरा बर्बाद कर दूची it is not fine okay if I go something called sine np.sine this is sine graph. Is it fine? No, it is also not fine. Go for cos, go for tan, anything you want, even keep on trying the things. Fine. So these are all manual techniques, guys. Keep on doing the things unless and until you are getting a normal distributed curve. If log is working for fine, then stop it. Stop there. Don't go ahead. Okay, this is fine. I'm still getting some points out of the line here because they are your outliers. As I told you, outlets effects are getting decreased. Previously, so many points were out of the line, but right now only 2 points are out of the line. So go and treat your outliers. Go and treat your outliers using mensuration. If you treat your outliers using mensuration, then these things would also be getting removed. Hello? Okay. Now, suppose I just want to execute something called box plot from scipy from scipy dot stats import boxcox. Okay, boxcox. Let me go and import it. That's got imported. So first, the thing that you need to do is initialize your boxcox. Boxcox. Initialize your boxcox. Okay. What I should be doing? Data. Or else I can go with something called a comma b is equals to your data set is df.boxcox. Now data frame. Let me go and showcase my data frame education. Go my data frame as well. Okay, fine. You can do something like this. This is one is education dot workx. That's fine. So it is working, boxcox education dot workx. So I implemented boxcox. Direct boxcox को import कर देली और implement कर देली. If I implement it, okay, if I implement it, as I told you, it will be going on calculating for lambda. See, lambda value what is lambda value is going to vary from -5 to 5. Along with that, it will use that particular formula. Okay, whatever formula x to the power lambda minus 1 divided by lambda. That particular formula is basically used when your lambda is not equals to 0 and your x values are greater or equals to 0. If your lambda value is getting 0, it will calculate for log x if your lambda value is equals to 0. Fine. Let's see what lambda value it has calculated. It has calculated one lambda value and that lambda value got stored inside B. ମୁଁ A, B ଦେଇଛି କାହିଁକିନା B ରେ lambda value store କରିବା ଆଉ A ରେ ଏଇ formula use କରିକି using this formula it will go and transform the things. So as you can see here, B value on my variable explorer, B value is given as minus 0.154. This is my lambda. Is this lambda equals to 0? No, this is not equals to 0. So it will keep on putting those lambda value and x values over this formula. तो ये formula use करके से data को transform कर देगा. Let's see those transform data. Let me have a look. तक मैं A receive कर ली. See here. This is your transform data, guys. This is your transform data. So data got transformed completely. Data got transformed completely. And if you take this particular data and put it over your QQ plot or probability plot, you would be getting all the points plotted over the line. Okay. So in the same way, you can also import U Johnson by U. What is that? U Johnson. Just import U Johnson. Utilize the same thing. I will be putting this time. Uh, Let me go for data and here comma re मुझे भी lambda data and lambda one or lambda one is equals to the same thing I will be using just like your box plot. U Johnson inside it I should be putting workx. That's it. Let me go and showcase you. U Johnson is not defined. I didn't run this. Now it is fine. Now this is fine. Now see here. This time the lambda one here A3 कौन से वेग रहेला? Lambda value I got using boxcox. Sorry, using U Johnson is nothing but 0.183, and it implemented that particular formula if your lambda value is not equals to 0 and if your values are greater than 0. Okay, so it will be going for what? X to the power x plus 1 to the power lambda minus 1 divided by lambda. This formula is going to be used. ହେଲା तो से प्रत्येक एक्स वैल्यू नेला लैम्बडा वैल्यू एथर कोन अछि -0.183 अछि तो एई फार्मूला हिसाब रे पकेकरी ट्रांसफॉर्म कर देला. लेट्स गो एंड सी दोस ट्रांसफॉर्म वैल्यूज. Those are got saved inside data. So let me go and showcase my data. So your data is like this. So here also the values got transformed. See, the values are so near to each other. As you can see, the values are so near to each other. So the variance should be very less. The variance is both less above. Your graph would be completely symmetric, is not it? पाखापाखि symmetric भला ଦେଖାଯିବ. Data ଏତେ vary କରୁନି. See, if your data is if your variance is not at all changing, same variance, equal variance को हमें कहू homoscedasticity. There is a term known as homoscedasticity. Homoscedasticity is the term basically used when you have equal variance. And we also call something called heteroscedasticity when two columns are having different variance. Okay, I'm comparing in terms of different columns. Okay, heteroscedasticity तो variance completely different. Anyway, these things again you will be learning and under machine learning techniques, but this is how the transformation happened. Okay, either you can use log directly or else you can take the help of boxcooks and use function. Let's use boxcooks and use function over the plotting. मैं plot रे यदि यूज कर देवी for example ये जो a, let me go and take this a को कॉपी कर ली. why? Because boxcooks मते a देछि मो stats इतरे जहाँ भी अच्छी, let me put it here, let me put it here, here, and let me go and plot it. Let's have a look. देखो At a box cox or Kamal. This thing I did because of box cox. Box cox gave me minus 0.15 as the lambda value, and I used my, and one column came up by calculating, on the original data transform values देला a को नेकरी मैं prop plot भीतर पके देली और ताकू run कर देली. As you can see here, data got completely transformed, is not it? In the same way, if I take data and put here, just to observe, again here the data got completely transformed. Okay, the use function use करो कि box cost use करो, these things are completely depending on you, which one you are using. Keep on trying, and ultimately you have to make your data transform. That's it. Okay, so that was something that you should be knowing. Okay, the data transformation is a powerful technique. Let's go for something called scaling. Scaling. Okay, did you understood? Did you understood? This topic, transformation.
Yes, sir.
Okay. Now we are having something called scaling. Scaling is another technique. For pre-processing point of view, scaling is another technique. Scaling is basically used when your data are present in different formats. Formats in the sense, different digits are present. For example, you have a column called salary. You have another column that is age. You have another column that is nothing but rate of interest, ROI, rate of interest. And a person wants to take loan. Salary values are given like this: 20,000, 40,000, 80,000, something like this. Age is given like 20, 30, 40, something like this. And rate of interest is given something like this: 0.1, 9%, 9.6. So here decimal places are there. Here there is no decimal places, but we have two digits. And here we are nearly having, five digit values. Are they properly present in a common format? No, the items or the values are not present in a common format. Here decimal places are there and one digit values are there. Here two digit values. Here five digit values. If I take my output column y is equals to, for example, ax1 plus ax2 plus ax3. X3. X1 is your salary, X2 is your age, and X3 is your rate of interest. Now, y will get influenced. Y will get influenced because of this big value, is not it? Because of this x1 is too high, five digits are there, and you are multiplying one constant over it. So again, it will be getting increased if your constant is greater than 0 or greater than 1. Fine. तो एक ही कॉलम की वजह से your y is completely getting diverted. Y is getting biased. We call it as biased. So this shouldn't be there. This shouldn't be there. Equal priority should be given to each and every column. So y should be depending on this one equally. Biasness ଏମିତି ନଥାଉ. ତ ଏଇ ଜିନିଷକୁ କରିବାକୁ ହେଲେ we should be using a technique called scaling. It will make the data scale free. It will bring out all the data to a common range. So a particular range ରେ ସବୁ data କୁ ନେଇକି ଆସିଯିବ. It will make the data present in a common range. Okay. Using one formula. So scaling techniques are also known as shrinking technique, data scaling technique. We also call it as feature scaling technique, feature shrinking technique. Fine. It will make the data unitless. Unitless in the sense, at the end of the iteration, at the end of using this formula, it will make the data in a particular range. ଯେତେବେଳେ particular range ରେ ମୁଁ ନେଇ ଆସିବି ସେତେବେଳେ salary ବୋଲି ଆମେ କିଛି ଜାଣିପାରିବାନି, ନା ହିଁ ଏଜ୍ ବୋଲି ଜାଣିପାରିବା, ନା ହିଁ ରେଟ୍ ଅଫ୍ ଇଣ୍ଟରେଷ୍ଟ ବୋଲି ଜାଣିପାରିବା. Can a salary be 0.23? No. Can a age be 0.6? No. That is the reason it will make the data unitless. The unit of value, meaning टा भी change करती है if you use scaling technique. Okay, the meaning of your units are going to be changed completely. So there are three types of famous scaling techniques. One is known as normalization, min max color, range method. Three names are given. You can remember normalization or min max color. That's fine. This technique uses a formula called x is equals to x minus x minimum divided by x maximum minus minimum. This formula uses, oh sorry, this particular technique normalization uses this formula. এই formula basis से काम करियो. Suppose you have a column. You have a column. Column values are given like 20, 30, 40, 10. This is a column. Let's use this formula. First x value कौन है जीवो xi. What is your xi? 20. 20 minus out of your entire column. What is the minimum value? 10. 10. Divided by x maximum minus minimum. What is the maximum value? 40. What is the minimum value? 10. Go and calculate it. You would be getting 10 by 30. 1 by 3. 0.33. 0.34 for example. 0.34 you want. This is your let me write it here. Corresponding लिख ली 0.34 बने देली. Go to the next one. If you go to the next one, it would be 30 minus 10 divided by maximum minus minimum. Again 30. 2 by 3. 0.67. If you go to the next one, if you calculate next x 40 minus what is the minimum value? Minimum value is 10 divided by maximum minus minimum 40 minus 10. It will be 1. If you go to the next one, you would be getting 0. Okay. So see here, you got a new column, you got a new column. This was your original column, and you got a new column. New column रे देखो dated आपका completely shrink ହେଇଗଲା. 20 become 0.34. 30 become 0.67. Values ଟା ପୁରା ଛୋଟ ହେଇଯାଉଛି. Shrink ହେଇଯାଉଛି. And all the values are coming within a particular range. Remember, if you use a technique called normalization, it will make the data scale free, unitless, shrink the values to a particular range. The range is from 0 to 1. All the data would be getting converted to a value. The value is lying from 0 to 1. This is the power of this technique, normalization. It is also known as min max color kind of denominator re maximum or minimum usage min max color. It is also known as range method. Why? Because range formula called maximum minus minimum. And here are we using the formula for range? Yes, we are using the formula for range. Fine. So normalization among all the data are going to be converted between 0 to 1. Between 0 to 1, so values would occur. In the same way, we have something called standardization. This is normalization of commerces. Standardization out of technique. Standardization, we are going to use a formula called x minus mu divided by sigma. This formula is used. Again, the same column 20, 30, 40, 10 salary column. X is nothing but 20. 20 minus mean. What is the mean of this column? 30, 40, 50, 60, 100. 100 by 4. 25. 25 is the mean. So 20 minus 25 divided by sigma. Again, you have to calculate the what is sigma? Standard deviation. Standard deviation of this column. Calculate it. Put it here. Get some output. It would output by it would output by it would output by it would output by. Remember, standardization is a technique that will make the data scale free or shrink the data in such a way that you would be getting all the values within a range. We don't know the range. We don't know the range here. We don't know the range, but the values are present in such a way that your final mean will be 0 and sigma will be 1. If you go and check out the mean value of this new column which got created because of this formula, you would be getting the mean value as 0 and the sigma value as 1. This will come up. See, केमिति करिवो कौन करिवो it will do by using this formula, and this formula itself will be making your final mean value as 0, sigma value as 1 for the new column. And if you ask me, sir, some range should be there. In general, range is from -3 to +3. In general, but it is not mandatorily present every time. But 99% of the case, a range ratio, 1% of the time you may get out of the range. Minus infinity to plus infinity भी aspire. Very rare cases. Based on the data points, based on the values. So standardization is a technique that will work in order to make your mean value as 0, sigma value as 1 for the final output. That's what standardization is. We have something called roboscaling. Roboscaling is a technique. Robust. This technique is basically used when you haven't treated your outlier. You have not when you haven't treated your outlier, ଯଦି ତମେ outliers କୁ treat କରନା ଆଉ ପଳେଇ ଆସୁଛ ଡାଇରେକ୍ଟ ଏଇ କାମ କରିବାକୁ, ତାହେଲେ roboscaling କୁ use କରିବ. Go and use something called roboscaling. Roboscaling is a powerful technique that will do its work, and it will be robust to your outliers. It is robust to your outliers. If you have outliers, then it will work fine. Why? Because it has been made in that way. Roboscaling ର formula ଆସୁଛି x minus median divided by IQR, and you should be knowing what IQR is. Remember when we were discussing about IQR was what IQR interquartile range was coming up for which particular topic? Outlier analysis, is not it? So whenever the thing comes up for outlier, you should be using roboscaling. Median is also a very good parameter, very good statistical parameter in order to handle outliers. तुम्हारा outlier है तो median use कर दियो. Why? Because median never gets influenced by outliers, but mean gets influenced. So this technique is basically used to give you a new column in such a way that just like your normalization and standardization, in such a way that your final data median value will be 0 and your IQR value will be 1. Your final data median value will be 0 and IQR value will be 1 if you use something called roboscaling. Remember one thing, these three techniques won't be changing the shape of your distribution. ତମ shape change ହେବନି, ଖାଲି values ଗୁଡ଼ାକ change ହେଇଯାଉଛି, shrink ହେଇଯାଉଛି ନା, ତ shapeଟା ଯେମିତି ଅଛି ସେମିତି ରହିବ, ସେ shape ସହିତ କିଛି ଛେଡ଼ଖାନି କରିବନି, it will simply change your values. So three things you need to remember if you are using normalization: your range would be from 0 to 1. If you use standardization, your mean value will be 0 and sigma value will be 1. If you use roboscaling, your median value will be 0 and IQR value will be 1. And this is something that you need to remember. And if you are remembering the formula, these formulas are easy to remember, so you can easily remember it. Fine. Now, if I go and showcase you the coding part of it, let's have a look. Okay, understood the theoretical things? What are these formulas made for? And why should you use this technique? When to use this technique?
Yes, sir.
This technique is a powerful technique and you shouldn't be taking it casually. Three things from pre-processing are mandatory to be done. Vinsorization, if you have outliers, then it will impact your model in future. Missing values, if you have missing values, then your output Y will not be able to get the analysis for your input. Missing values. Another one is scaling. If you want to do scaling, then some of the models will hamper your accuracy, especially when you are using the models which requires distance calculation. Distance ଯେତେବେଳେ calculation କରୁଛ, root over of x1 minus x2 whole square plus y1 minus y2 whole square ଧର କରୁଛ, suppose this is a formula. ଯଦି x1 ଭ୍ୟାଲୁଟା ତମର ଅଛି 2000 ଆଉ x2 ଭ୍ୟାଲୁଟା ତମର ଅଛି 2. So what is 2000 minus 2 the whole square? So your output would be getting impacted because of this big number. Because of this big number, and this number is very small, your resultant output would be big. And तार पुणी square करछो तो तमरो final output टा पूरा एपट सपट हो जिवो. That is the reason why before undergoing any of the mathematical techniques, especially this distance calculations or some advanced techniques like ଅଛି କିଛିଟା ଯେମିତି ଇକ୍ୱେସନ୍ ବନାଉଛ, if you have something called equation based ଯଦି କିଛି କରିବାକୁ ଚାହୁଁଛ, ତ ଶ୍ରିଙ୍କିଂ ଟେକ୍ନିକଟା ୟୁଜ୍ କରିବା ନିହାତି ସେଠି ଦରକାର. ଆଗରୁ ଶ୍ରିଙ୍କିଂ କରିଥିଲେ ସବୁ ଡେଟା ପଏଣ୍ଟସକୁ ଇକ୍ୱାଲ୍ ପ୍ରାୟୋରିଟି ସହିତ ଦେଖିବ. No one is big, no one is small. Every data points are lying within a particular range or they are following some criteria, just like standardization होगी, roboscaling criteria. Okay, then only it will work. So this process is very much powerful. And yes, encoding is case basis ଦରକାର. encoding କୁ ତେବେ ନବ ଯେତେବେଳେ ତମର कैटेगोरिकल डेटा थी यदि कैटेगोरिकल नहीं एनकोडिंग का ऊपर करियो किस तो दरकार नहीं ओके तो एटा केस बेसिस एनकोडिंग ओके now if I go and showcase you the coding part of it. Okay. I will be sharing this code to you. Whatever we had discussed, you need to run it once. Okay, so that you will be getting some idea, fair idea. So say use function lagi kiri mu karchi. And remember, use function is a part of SciPy. It is also a part of feature engine. ତମେ ରନ୍ କରିବ ଜାଣିବ କି ଗୋଟେ ଜିନିଷକୁ ଆମେ ଦୁଇଟା ତିନିଟା ଲାଇବ୍ରେରୀ ୟୁଜ୍ କରିକି ବି କରିପାରିବା ଦ୍ୟାଟ୍ସ କମ୍ପ୍ଲିଟଲି ଫାଇନ୍ ଅଲ୍ଟିମେଟଲି ୟୁ ୱିଲ୍ ବି ଗେଟିଂ ଦ ସେମ୍ ଆଉଟପୁଟ୍ no changes at all. Okay, standardization, normalization, pandas PD, numpy ये. Let me go and import a dataset called empty cars dataset. If I go and showcase you data, this is your cars dataset. ध्यान से देखो MPG 21 cylinder 6 displacement 1 horsepower 110 2 digit single digit 3 digit decimal places decimal places तापर 014 एमती सब अच्छे तो data should be shrinked data are present in different formats different columns are having different data हमें तो कोई particular range को आने को पड़ेगा okay in order to make to a particular range let's go and use standard scalar first ଯଦି standard scalar କରୁଛ ତାର କ'ଣ property ରହୁଛି remember whenever you are using these things try to remember the properties of it standard scalar will make your final output in such a way that you will be getting mean value as 0 sigma value as 1 which formula it will be trying to use x minus mu by sigma it will calculate the mean of that entire column sigma of that entire column अब प्रत्येक x value सहित minus करिके divide करिवो sigma ଗୋଟେ value पाइबो standard scalar let me go and import it and this is going to be imported from sklearn is the library scikit-learn ସେଇଠୁ import ହେବ I imported it initialize କରିବି ଯେମିତି visualization initialize କରୁଥିଲି initialize କରିବାକୁ ପଡ଼ିବ let me go and create one engine it is just like creating one engine initialize it I initialized it and simply use fit underscore transform fit it over your data entire data ଉପରେ fit କରିବାକୁ ଚାହୁଁଛି let me go and do it that's fine ହେଲା I did it let me go and check it out अरे भाई ये तो ହେଇଗଲା ये ହେଇ ତ ଗଲା but see ଆମେ ଜାଣିପାରୁନୁ ଆରେ ଏଟା କୋଉ କଲମର କ'ଣ ଥିଲା column names got removed previously my column names were mpg horsepower something like that ଏବେ 01 to ଆସିଗଲା କ'ଣ କରିବା let me first change it to one data frame ଏବେ ଯୋଉ output ଟା ପାଇଲା କୋଉଥିରେ ଆସିଲା see the type array you got the output in terms of array let me go change it to data frame pd.dataframe simply लिखिदବ simply if you write down pd.dataframe then things are going to be changed to a data frame format still you don't have your column names କ'ଣ କରିବା columns let me use columns is equals to let me retain those columns data data dot columns data dot columns रे ही सॉरी ये जो डेटा इज नथिंग बट माय डेटा फ्रेम ए डेटा फ्रेम रे जो जो सब कॉलम्स थिला सेही कॉलम्स को नेली डेटा डॉट कॉलम्स मींस दोस कॉलम्स व्हिच आर पार्ट ऑफ योर डेटा टेक दोस थिंग्स पुट इट अंडर कॉलम्स ऑफ दिस पर्टिकुलर डेटा सेट ए डेटा फ्रेम पकड़ दिया इफ आई डू इट थिंग्स डन एमपीजी सिलेंडर डिस्प्लेसमेंट सब गुड़ा आसी परफेक्ट नाउ सी हाउ द थिंग्स केम अप कोथरे माइनस लगी कोथरे प्लस अच्छी but see the range the values are near to each other is not it many of the values are almost all the values are near to each other पाखापाखी सब go and describe it you know what describe is describe function will be helping you to get through some of the parameters let me use it res ଏବେ ଦେଖ
statistical parameter.
see here as I told you standard deviation 1 थिबो mean थिबो तमर 0 means sigma mean now you should not be saying कि sir এটা তো mean 0 लिखा ही नहीं this is nothing but minus 4.9 into 10 to the power minus 16 e minus 16 means 10 to the power minus 16 10 to the power minus 16 means 0.0000000000049 15টা 0 ପରେ 49 ଆସୁଛି so it is 0 it is also 0 it is 0 ये तो डायरेक्ट 0 ଦେଇଦେଲା so all these things are 0 so प्रत्येक कॉलम ପାଇଁ ସେ mean value 0 ବନେଇଦେଲା coming to sigma standard deviation 1.01 it is one only 1 1 1 1 1 1 so So standard deviation mean value got changed 0 1 ହେଲା। ଏବେ ତମେ ଯାଇକିରି distance formula ପକାଅ କି କୋଉ prediction ଉପରେ କାମ କର, that's completely fine, you can use it in future. Your data is completely transformed, it is ready to be used. Now one more question,
Tell that.
is it removing your outliers? Is it removing your outliers?
No.
Here also outlier remove होनी, खाली outliers का effect टा shrink ही जाउची, effect shrink ही जाउची, outliers are still persisting, outliers are still persisting, so the effects are decreasing but outliers are still there. So this could be a controversial question to be asked. आम ये टेक्निक यूज कले स्टैंडर्ड स्केलर आउटलायर पड़ोची कि नो आउटलायर जाऊनी, आउटलायर रोचे कि एफेक्टा कमी जाऊँ बिकज दे आर गेटिंग श्रिंक्ड, से बहुत बड़ वैल्यूटा छोट ही पड़े आस। ओके, सो ये जिनसा टी माइंड रख, दिस इज अबाउट स्टैंडर्ड स्केलर एंड वन मोर थिंग, स्टैंडर्ड स्केलर हम यूज केत करवा, रिमेंबर स्टैंडर्ड स्केलर बेसिकली यूज्ड व्हेन यू हैव approximate Gaussian distribution। आगे केडी प्लॉट चेक कर दबो, यदि जान लो कि अप्रोक्सीमेटली गॉसियन अछि और नॉर्मल अप्रोक्सीमेटली नॉर्मल डिस्ट्रीब्यूशन अछि तमर, ताको तमे स्केल फी करे चाहछो, गो एंड यूज स्टैंडर्ड स्केलर। ओके, काइना एथरे सिग्मा रो यूज होची, मीन रो भी यूज होची, and these two techniques are basically used when your mean value is coming up here, somewhere here center रे। तो ये गॉसियन डिस्ट्रीब्यूशन थी, आउटलायर्स थी कि कम थी बहुत कम आउटलायर को तुम ट्रीट करके आगे आस, देन गो एंड यूज स्टैंडर्ड स्केलर, दैट्स फाइन। आउ गोटे नले आउ गोटे वे,
ताମାନେ
आउ गोटे वे अच्छी, तुम प्रत्येक कलम देखीदेव, जदि बाइनरी वैल्यूज अच्छी ताहले ये टेक्निक टाको इग्नोर करिवो। जदि किछिटा कलम रे बाइनरी वैल्यू अच्छी, प्लीज इग्नोर दिस, व्हाई बिकॉज बाइनरी वैल्यूज को हैंडल करिया को नॉर्मलाइजेशन अच्छी ना, नॉर्मलाइजेशन टेक्निक मीन मैक्स स्केलर सी कौन करे 0 ରୁ 1 भितर दबो, 0 ରୁ 1 भितर वैल्यू दबो, तो सी कौन करिवो ए कलम गुडा को इग्नोर मार दबो, टाइम बची जीवो बिकॉज दीज आर ऑलरेडी प्रेजेंट इन 0 1 फॉर्मेट। सो मीन मैक्स स्केलर तबे यूज करिवो जतले 0 1 फॉर्मेट रे आइटम्स गुडा को पाउचो, किछि ना किछि तो यदि कलम अच्छी अजथरे परिश्रम करा दरकार नहीं, बट यूज स्टैंडर्ड स्केलर इफ ऑल योर डेटा आर समथिंग लाइक दिस, एज नो एज हो गला, सैलरी हो गला, रेट ऑफ इंटरेस्ट समथिंग समथिंग कोथरे 0 1 फॉर्मेट रे किछि आइटम्स नै, यदि नहीं गो एंड प्रिफर दिस स्टैंडर्ड स्केलर, से वे रु देख परिबो नले देख परिबो गॉसियन डिस्ट्रीब्यूशन जदि अछि देन दैट इज गोइंग टू बी वर्क आउट फाइन हैला। So it is completely up to you how you are using, which one you are using, it's completely up to you, किछि एमथि बड़ा असुविधा नुहे। Anyway, if you are getting bad accuracy, come here instead of standard scalar, use min max scalar, just try it once, it's all about experiment।
ताମାନେ जदि नॉर्मल डिस्ट्रीब्यूशन अछि वैल्यू अधिका अछि सेटा खाली श्रिंक करिया पय हमें एटा स्केलर
स्टैंडर्ड
करू,
स्केलर यूज कर दो।
स्टैंडर्ड स्केल।
आ जदि बहुत सारा आउटलायर्स अछि आ तुम डेटा एकदम से असिमेट्रिक अछि आ मेनी आउटलायर्स आर प्रेजेंट, ओके इट इज नॉट सिमेट्रिक एट ऑल, इट इज नॉट इवन नियर टू सिमेट्रिक, गो एंड यूज min max color, it will work fine। कारण से पूरा पर्टिकुलर रेंज को नहीं आछी 0 ରୁ 1 पूरा फिक्स्ड, 0 ରୁ 1 माने 0 ରୁ 1, ना ही माइनस को जीवो ना ही 1 ठाରୁ अधिक जीवो, किंतु स्टैंडर्ड स्केलर रे आगुरु ही आमे जानु कि भाई एटा पूरा गोटे नॉर्मल डिस्ट्रीब्यूटेड कर्व अछि पाखा पाखी अछि हैला, ताको हम श्रिंक करिवो दैट्स फाइन। से जहाँ रेंज अच्छी खाली ताको मॉडिफाई कर दबो, से जेमति को फिक्स्ड रेंज नहीं तार 0 ରୁ 1 भितर मु देबी, तार एमति कि फिक्स्ड रेंज नहीं, किंतु कुहा जाय कि -3 to 3 भितर से प्राय दिए। ओके, -3 to 3 भितर एथि पय दिए बिकॉज ऑफ सम कांसेप्ट कॉल्ड 3 सिग्मा, 3 सिग्मा प्लस माइनस 3 सिग्मा कांसेप्ट जे यूज करंती सेतिर 99.7% ऑफ द आइटम्स पळे आसे। Okay, so based on that particular logic, -3 to 3 most of the time तमे पाइबो पॉइंट्स गुड़ाक श्रिंक हो, बट इट इज नॉट मैंडेटरी, मैंडेटरी नुह, आठू पछू जापर आठू आगू भी जापर।
ताले एटा ଆମେ ଆଉଟଲାୟର ଆନାଲିସିସ୍ କଲା ପରେ
ସ୍କେଲିଂ, ହଁ
ସ୍କେଲିଂ
ସ୍କେଲିଂ
ମେଥଡଟାକୁ
ଟେକ୍ନିକଟା
ୟୁଜ୍ କରୁ।
ପ୍ରାୟ ପ୍ରିଫର ହୁଏ ଲାଷ୍ଟକୁ, ପୁରା ଏଣ୍ଡକୁ। ସ୍କେଲିଂଟାକୁ ବେସିକାଲି ତୁମେ ୟୁଜ୍ କରିବ ଏଣ୍ଡରେ। ତମ ସବୁ ସାରିଯାଇଥିବ, ଆଉଟଲାୟର ଆନାଲିସିସ୍ ହେଇଗଲା, ଏନକୋଡ଼ିଂ କରି, ଯଦି ଏନକୋଡ଼ିଂ କରିଦେଇଛ ଏଠି 01 ଫର୍ମାଟ୍ରେ ନେଇ ଆସୁଛ, ଯଦି 01 ଫର୍ମାଟ୍ରେ ନେଇ ଆସୁଛ ତାମାନେ ସ୍କେଲିଂ ଆଉ ୟୁଜ୍ କରିବ କି, ଏ ଯେଉଁ ଷ୍ଟାଣ୍ଡାର୍ଡ ସ୍କେଲାର ୟୁଜ୍ କରିବ କି? ନା, ମିନ୍ ମ୍ୟାକ୍ସ ସ୍କେଲାର ୟୁଜ୍ କରିଦେବ, ବେଟର୍ ହେବ। କାହିଁକିନା ଆଗରୁ କେତେଟା କଲମ୍ ତୁମ 01 ଫର୍ମାଟ୍ରେ ଅଛି। ହଁ, କାହିଁକିନା ଏନକୋଡ଼ିଂ କରୁଛ, ଏନକୋଡ଼ିଂ ଧର 1 ହଟ୍ ଏନକୋଡ଼ିଂ କରୁଛ, ତ 01 ଫର୍ମାଟ୍ରେ ଆଗରୁ କେତେଟା କଲମ୍ ବନିଯାଇଛି ନା, ତା ଉପରେ ଆମ କାମ କରିବାର ନାହିଁ, ଆମ ରେଷ୍ଟ
ହୁଁ
କଲମ୍ ଉପରେ କାମ କରିବାର ଅଛି। ତ ଅଯଥାରେ ସ୍କେଲିଂକୁ ନେଲେ ସେ ପୁଣି 10କୁ ପୁଣି ବି କନଭର୍ଟ କରିଦେବ। ଯଦି ଆମେ ଷ୍ଟାଣ୍ଡାର୍ଡ ସ୍କେଲାର ୟୁଜ୍ କରୁଛୁ, ସେ 01କୁ ବି କନଭର୍ଟ କରିକି କ'ଣ ଅଲଗା ନମ୍ବର ଦେଇଦେବ। ତ ଆମକୁ ଛୁଇଁବାର ନାହିଁ ଏସବୁ ଜିନିଷରେ, ଇଏ ଆଗରୁ ରେଡ଼ିମେଡ୍ ଆଭେଲେବଲ୍। ତ ମିନ୍ ମ୍ୟାକ୍ସ ସ୍କେଲାର ୟୁଜ୍ କର, ମିନ୍ ମ୍ୟାକ୍ସ ସ୍କେଲାର ୟୁଜ୍ କଲେ ଏଇ ଜିନିଷକୁ ସେ କମ୍ପ୍ଲିଟଲି ଇଗ୍ନୋର ମାରିଲା, ବାକି ଗୁଡ଼ା କଲମ୍ରେ କାମ କରିବ। Hmm. देखो min max color, if I use this min max color, and one more thing guys, let me it तुमको ଗୋଟେ ନୂଆ ଜିନିଷ ବତେଇବି, but it is not even necessary. Okay, let me go for something called a ବୋଲି ଗୋଟେ ବନେଇଦେବି, and I will be using scalar dot inverse transform, and this is nothing but my data set. Fine, see here, let me କାମ କରୁଛି କି ନାହିଁ ଦେଖିଦେବା। ୟା ଇଟ୍ସ working। ଧର ତମେ ସ୍କେଲିଂ କରିଦେଇଛ ଆଉ ତମର ଡେଟା ସେଟ୍ଟା ବି ଏମିତି ଦେଖାହେଉଛି, ପୁରା ସ୍କେଲ୍ ହେଇଗଲା, ସ୍କେଲ୍ ହେଇଯାଇଛି, ସିଙ୍କ ହେଇଯାଇଛି। ତମେ ଭାବିଲ ଆରେ ନାଇଁ ରେ, ମୋତେ ଏଇଟା କରିବାର ନଥିଲା, ମୋତେ ମିନ୍ ମ୍ୟାକ୍ସ ସ୍କେଲାର କରିବାର ଥିଲା ରେ, ମୁଁ ଏବେ ପଛକୁ କେମିତି ଯିବି, ରିଭର୍ସ ମୁଁ କେମିତି ଯିବି, ହେଲା କି ଅଣ୍ଡୁ କେମିତି କରିବି। ୟୁ ୱାଣ୍ଟ ଟୁ ଡୁ ଦ ଅଣ୍ଡୁ ଅପରେସନ୍, ସମଥିଙ୍ଗ ଇଜ୍ ଦେୟାର ଇନଭର୍ସ ଟ୍ରାନ୍ସଫର୍ମ କରିଦେଇଛ, ମୋତେ ପୁଣି ୱାପିସ୍ ଯିବାର ଅଛି, ପଛକୁ ଯିବାର ଅଛି, ଯାହା ଯେମିତି ଥିଲା ଅରିଜିନାଲ ଡେଟା। ଇନ୍ କେସ୍ ତୁମେ ଅରିଜିନାଲ ଡେଟା ଉପରେ ହିଁ ଚେଞ୍ଜ କରିଦେଇଛ, ତା ପାଇଁ ମୁଁ କହୁଛି। ଯଦି ଅରିଜିନାଲ ଡେଟାକୁ ସେପାରେଟ୍ ରଖିଛ ଦ୍ୟାଟ୍ସ ଫାଇନ୍। ଯଦି ଅରିଜିନାଲ ଡେଟାକୁ ହିଁ ସେପାରେଟ୍ କରିଦେଇଛ କିନ୍ତୁ ତୁମେ ଯାଉଛ ଅଣ୍ଡୁ ଅପରେସନ୍ କରିବାକୁ, ଇଫ୍ ୟୁ ୱାଣ୍ଟ ଟୁ ଗୋ ବ୍ୟାକ୍, ୟୁ କ୍ୟାନ୍ ୟୁଜ୍ ଇନଭର୍ସ ଟ୍ରାନ୍ସଫର୍ମ ଓଭର ୟୋର ଡେଟା ସେଟ୍। ଓକେ, ଓଭର ୟୋର ଡେଟା ସେଟ୍ ଇଜ୍ ନଥିଙ୍ଗ ବଟ୍ ଏବେ ଯେଉଁ ଟ୍ରାନ୍ସଫର୍ମ ହେଇଯାଇଛି, ଯେଉଁ ଟ୍ରାନ୍ସଫର୍ମ ହେଇଯାଇଛି ତାକୁ ଏଠି ପକାଇ ଦିଅ, ଆଉ ଗୋଟେ ଫଙ୍କସନ୍ ୟୁଜ୍ କର ଇନଭର୍ସ ଟ୍ରାନ୍ସଫର୍ମ। ଯଦି ସେଟା କରିବ ତୁମକୁ ଅରିଜିନାଲ ଡାଟା ମିଳିଯିବ। ଦେଖ ଅରିଜିନାଲ ଡେଟା ଏ 21 ଏସବୁ ଥିଲା ନା ଆଗରୁ ଅରିଜିନାଲ ଡେଟା। ପୁଣି କଲମ୍ ନେମ୍ସରେ ପୁଣି ଚେଞ୍ଜ କରିଦେବ ଏଠି। ଓକେ, କଲମ୍ ନେମ୍ସ କରିବାକୁ ହେଲେ a.columns is equals to data.columns, a.columns equal data.columns। columns ଓକେ, ଆଉ ଏଇଟା ମୁଁ ଡେଟା ଫ୍ରେମ୍ରେ ଚେଞ୍ଜ କରିବି, ଏଇଟା ଗୋଟେ ଆରେରେ ଅଛି, ଏଇଟା ମୋର କ'ଣ କରିବା, pd ଡଟ୍ ଡେଟା ଫ୍ରେମ୍। ଲେଟ୍ ମି କପି ଦିସ୍ ୱାନ୍, ତାକେ ଡେଟା ଫ୍ରେମ୍ରେ କନଭର୍ଟ କରିଦେଲେ ତୁମର ଫାଇଦା ଅଛି, ସବୁ ପ୍ରକାର ଅପରେସନ୍ ତା ଉପରେ କରିପାରିବ। ଲେଟ୍ସ ସି, ରେଡ଼ି, MPG, cylinder, displacement, everything came up, all the columns came up। ତମେ ରିଭର୍ସ କରିଦେଇଛ, ଇନଭର୍ସ କରିଥିଲ, ଇନଭର୍ସର ଉଲ୍ଟାଟା କରିଦେଲ, ମାନେ ପଛକୁ ପୁଣି ଗଲ, ଅଣ୍ଡୁ କଲ। ସୋ ଅଣ୍ଡୁ ଅପରେସନ୍ ଇଜ୍ ଆଭେଲେବଲ୍ ସ୍କେଲିଂରେ। ଓକେ, କିନ୍ତୁ ୱିନ୍ସୁରାଇଜେସନରେ ଆପ୍ଲାଏ ହେବନି, ୱିନ୍ସୁରାଇଜେସନରେ ଅଣ୍ଡୁ କାମ ଚଳିବନି। ତ କିଛି କିଛିଟା ଫଙ୍କସନ୍ ପାଇଁ ହିଁ ସେ ଆପ୍ଲିକେବଲ୍ ରହୁଛି, ମିନ୍ ମ୍ୟାକ୍ସ ସ୍କେଲାର, ଷ୍ଟାଣ୍ଡାର୍ଡ ସ୍କେଲାର, ଏନକୋଡ଼ିଂରେ ବି ରହିବ। ହଁ, ଓକେ, ଦେଖ ମିନ୍ ମ୍ୟାକ୍ସ ସ୍କେଲାର, ଲେଟ୍ ମି ଟ୍ରାଇ ଆଉଟ୍ ମିନ୍ ମ୍ୟାକ୍ସ ସ୍କେଲାର, again initialize it, min max color, go and apply it over your data, that's it, simply data ଉପରେ କାମ କରିବ। Let me go and showcase my data is fine, let me go and operate it, done। ଯଦି ହେଇଗଲା, ଡେଟା ଫ୍ରେମ୍ରେ ଚେଞ୍ଜ କରିଦିଅ, ଡେସ୍କ୍ରାଇବ୍ କରିଦେବି, ସବୁ values 0 1 ଫର୍ମାଟ୍ରେ ଆସିଥିବ, ରିମେମ୍ବର all the values would be lying between 0 and 1। if I go and showcase you, minimum value is 0, maximum value is 1, so all the values are present between 0 and 1।
ମୁଁ କିଛି ପର୍ଟିକୁଲାର କଲମ୍ ନେବି, ହେଲେ ସେଟା
ହଁ
ଲେଖିବାକୁ
ହଁ
ପଡ଼ିବ
ହଁ,
ପୁଣି।
କିଛି ଅସୁବିଧା ନାହିଁ, ଲକ୍ ଲଗେଇଦେବ। ଫର୍ ଏକ୍ଜାମ୍ପଲ୍ ମୋତେ ଦରକାର, ଏଇଟା କ'ଣ କାହା ଉପରେ କାମ କରୁଛି, ଡେଟା ଉପରେ। ୱେର୍ ଇଜ୍ ମାଇ ଡେଟା ଇଏ ହେଲା, ମୋତେ କେତିକି ଦରକାର, MPGରୁ Q ସେକେଣ୍ଡ ଯାଏଁ ଦରକାର ନା। ହଁ
ହଁ, ସେ ଦିଟା ହଉ କି ଯୋଉ ଏନି ଆର୍ବିଟାରୀ ହଉ, କଲମ୍ ମୋର
ହଁ,
ଦରକାର
ଠିକ୍ ଅଛି,
ଚାରି ପାଞ୍ଚ।
ଏମିତି କରିଦେବ, ଇଏ ହେଲା ନା। ଡେଟା ଡଟ୍ ଆଇଲକ୍ ଲଗେଇ ଦିଅ, ଶିଖିଛ ନା ଆଇଲକ୍। all rows कॉलम केतेटा धर दुटा तीन कॉलम लिखर अच्छे 0,1,2 इंडेक्सिंग पोजिशन यूज हो आई लॉक रे इंटीजर लोकेशन यदि मुझे एलओसी
ହୁଁ
पकई था लॉक ताले कॉलम रो ना पकई था है
ହଁ
एटा जाई रन कर देबी सिंपल रन हो गला df अंडरस्कोर n रे एक मु चेक करी ए तीनटा नेथिले तीनटा रही गला
अभी तीनटा अंक को ମୁଁ ଆଡ୍ କରିବି ଅରିଜିନାଲ डाटा ଇଏରେ
हां यदि ऐड करे
ସେଟା
अछि कॉनकैट कॉनकैट
concat
हां d is equals to pd dot concat pd dot concat कौन I have to go with कौन गला एटा df underscore n गोटे रहिला data access 1 ना 0 रहइबो
1
1 that's it concat position okay do one thing एटा bracket रहइबो now it's fine classes and receiving interpret mobile leader concat x is equals to 1 pd dot concat कौन ब्रैकेट रे कौन आसे कैन नॉट कंप्लेंट ऑब्जेक्ट क्लास ओके वैसे आरए फॉर्मेट रे अछि रे ताको आगे डेटा फ्रेम रे तो चेंज करिवि आइ था से पय हम देखौछ नाउ इट इज फाइन क्लास एंड एरिया ओनली सीरीज तो कौन अछि डेटा सेट 1 हला ये रे डेटा हे गला तमर ये रे डेटा सेट कौन वाला df of an data set yeah 3 years fine concat cannot complete an object of type class and only series and data frames are valid. Series and data frames are valid. Okay, is it because of some? Now is it fine? Syntax account problem कुछ. D is equals to pd dot concat shared data frame. Oh, अरे अरे एठी हम डेटा सेट 1 लिखियार थिला मु सेटा df underscore n लिखछि डेटा सेट another one is data that's fine now give us something called access is equals to 1 x equals to 1 let's run it now it's fine hello आड़े गला ए तीनटा आड़ेला 0 1 2 तापर एमपीजी हरिका सब थिला
ହୁଁ
so you can use concat if the axis equals to 1 पके पड़िबो if you don't put axis equals to 1 से कोन करिवो तळକୁ नै जिवो माने axis equals to 0 हिसाब रे बाय डिफॉल्ट काम
ତ
कर दो
ହଁ
okay now
ତାହେଲେ ମୁଁ କହିଲି ଟ୍ରାନ୍ସଫର୍ମେସନ ଟା ଆମେ ୟୁଜ କରିବା କେବଳ ଇଏ ମାନେ ବଡ ଭ୍ୟାଲ୍ୟୁ କି କୌଣସି ଭ୍ୟାଲ୍ୟୁ ଥିଲେ ତାକୁ ସ୍ଟ୍ରିଙ୍ଗ କରିବା ପାଇଁ
ट्रांसफॉर्म नॉर्मलाइजेशन था
ନାଇଁ ଟ୍ରାନ୍ସଫର୍ମେସନ ଫାଷ୍ଟ ଯୋଉଟା
पढ़िले
ପଢିଲେ ଆଜି
देखो
ହୁଁ
ट्रांसफॉर्मेशन इज बेसिकली यूज्ड टू मेक योर डेटा नॉर्मल बढ़िया आगे नॉर्मल फॉर्म रे नहीं आइलो यदि ट्रांसफॉर्मेशन यूज करूछ डेटाटा नॉर्मल फॉर्म रे आसीगला माने पूरा यदि हिस्टोग्राम प्लॉट
ହୁଁ
करिवो पूरा एमती आसीगला ताहेले बढ़िया तमे जेकी श्रिंकेज करियर अछि बेस्ट वे इज स्टैंडर्ड स्केलर यूज कर दियो
ତାପରେ ସ୍କେଲିଂ ମେଥଡ ୟୁଜ କରୁଛେ ତାକୁ ଗୋଟେ ନର୍ମାଲ ରେଞ୍ଜ କୁ ଆଣିବା
स्पेलिंग
ପାଇଁ
मेथड यूज करा होची हां यूनिटलेस करिया को श्रिंक करिया को आगुर तो से श्रिंक भी हेक रहिथबो यूनिटलेस कर दो हां इन केस मोरो ए
ୟୁନିଟଲେସ୍ ମାନେ କଣ
यूनिटलेस माने देखो फॉर एग्जांपल सैलरी अछि मोर 20000 एज अछि मोर 20 इयर्स ओल्ड 20000 और 20 इयर्स ओल्ड आमे सेपरेट करि पड़छ बिकॉज ऑफ रुपीस 20000 ये हला 20 इयर्स जेतो श्रिंक हे जाउची सी गोटे टेक्निक पकाउची कोन स्टैंडर्ड स्केलर यूज करो कि मिन मैक्स स्केलर यूज करो आको कोन दोउची से 0.2 दे दोउची आको दे दोउची 0.3 एबे 0.2 को आमे रुपीस कहि परिबो कि ना रुपी 0.2 कि 0.3 इयर्स ओल्ड आंकर मीनिंग और रहिलानी ये यूनिट रो मीनिंग और किछ रहिलानी से से यूनिट लेस कर दो ୟୁନିଟ୍ର କିଛି ମିନିଂ ହିଁ ରଖିଲାନି ସ୍କେଲିଂ ପରେ, ସବୁଗୁଡ଼ାକୁ ଇକ୍ୱାଲ୍ ପ୍ରାୟୋରିଟି ଦେଇଦେଲା, ତ ସେଥିପାଇଁ ୟୁନିଟଲେସ୍ ତାକୁ କୁହାଯାଉଛି। ଏବେ
ଆଚ୍ଛା ତାହେଲେ ଟ୍ରାନ୍ସଫର୍ମେସନ ପରେ ସ୍କେଲିଂ
ଟ୍ରାନ୍ସଫର୍ମେସନ୍, ହଁ ଯଦି
କରିବା ଉଚିତ।
ଟ୍ରାନ୍ସଫର୍ମେସନ୍ ହେଉଛି ତାମାନେ ଡେଟାଟା ନର୍ମାଲ ହେଇଗଲା, ଗସିଆନ୍
ହଁ
କର୍ଭ ହେଇଗଲା। ଯଦି ଗସିଆନ୍ କର୍ଭ ହେଇଗଲା, ଗो ଫର୍ ଶ୍ରିଙ୍କିଂ। ଶ୍ରିଙ୍କିଂ ଟେକ୍ନିକ୍ ପାଇଁ ବେଷ୍ଟ ହେଲା ଷ୍ଟାଣ୍ଡାର୍ଡ ସ୍କେଲାର। ଷ୍ଟାଣ୍ଡାର୍ଡ ସ୍କେଲାର ବଢ଼ିଆ।
ହୁଁ
ସିଚୁଏସନ୍ ଟୁ ସିଚୁଏସନ୍ ବେସିସ୍ରେ ଯାହା କରିବା କଥା କରିବ। ଏନିୱେ କେଉଁଟା ବି ୟୁଜ୍ କର, ତୁମର ଅଲ୍ଟିମେଟଲି ତୁମକୁ ସ୍କେଲ୍ ଫ୍ରି କରିବାର ଅଛି। ହୁଁ। ଆଉ ରୋବୋ ସ୍କେଲିଂ ଇଜ୍ ଏକ୍ସେପସନାଲ୍। ଯଦି ତୁମେ ଭିଜୁଆଲାଇଜେସନ୍ କରିନଥିବ, ଡାଇରେକ୍ଟ ଯାଇକି ସ୍କେଲିଂ କରିବାକୁ ଟ୍ରାଏ କରୁଛ, ଯେଉଁଥିରେ କି ଆଉଟଲାୟର୍ସ ଅଛି, ଏ ଆଉଟଲାୟର ଉପରେ ଭଲ କାମ କରେ। ଆଉଟଲାୟର୍ସ ଉପରେ ଏକ୍ସ ମାଇନସ୍ ମିଡ଼ିଆନ୍ डिवाइड बाय क्यूआर, ए टेक्निक हिसाब से काम करियो। एक्स माइनस मीडियन डिवाइड बाय क्यूआर। ହେଲା, ତେବେ ଦେଖିବା ରୋବୋ ସ୍କେଲିଂ। रोबो स्केलिंग इज अ वेरी effective task, है कि जब तुम्हारे आउटलायर्स थी वो देन आउटलायर्स आर गोइंग टू बी हैंडल्ड आउट बिकॉज ऑफ रोबो स्केलिंग। तो सिंपली आपको जाके रन करियो रोबो स्केलिंग यूज कल, रोबो स्केलर यूज कल। रोबो स्केलर इज नथिंग बट अ फंक्शन इनिशियलाइज कल जेम सेठी करथलो। फिट अंडरस्कोर ट्रांसफॉर्म कर दबो ओवर योर डेटा सेट, दैट्स फाइन। डेटा फ्रेम रे चेंज कर देलो और डिस्क्राइब कर देलो। वन डिस्क्राइब इट, इफ यू डिस्क्राइब इट मीडियन वैल्यू कोन हिजिवो? If you go and describe it, then the median value
0,
0 and IQR value 1.
1.
Check करिए, let's go and check it out. RES robust, let's have a look. मीडियन वैल्यू 0 थी दरकार। अच्छा आंक भीतर कोटा मीडियन वैल्यू कहलो 50th परसेंटाइल। सी 0 0, दिस वन इज 0, सबुटा 0 हो गला। व्हाट इज IQR? Q3 minus Q1, Q3 minus Q1 माने 75th परसेंटाइल minus 25th परसेंटाइल। हेलो, and you can have a look 75th percentile ये 25th percentile याको को माइनस कर लो। 0.48 minus of minus 0.51, if you simply do it you would be getting 1. 0.5 minus of minus 0.5, 0.5 plus 0.5, it is 1. So every time you are going to get 1. हेलो, तो ये ला रोबो स्केलिंग। ओके Rishita, did you understood?
Yes, sir.
Okay, fine. So I will be sharing this code with you all, and along with that, although I'm recording the sessions and all, so I'm putting it over my drive. Okay, so go through it if you want to, again revise these things.